so next let us move on to partial differentiation of vector point function. So in order to define the partial differentiation, we require a vector which is say defined in three variables, say x, y, z. So suppose we wanted to define the partial derivative of this vector with respect to the variable x. So according to definition for this derivative, what we will do, we will seek only the change in x variable here, and we will keep the second variable y as such, the third variable z as such, right? There is no change in all of these, and that is what we do. We treat this y to be constant and the variable z also to be constant. So this defines the partial derivative of the vector f. Whenever you write vector, you always write this arrow on top of it, right? So its partial derivative with respect to x is given by this definition. Similarly, we can also define the derivatives corresponding to y and corresponding to z. So what are these? These are the first order derivatives, partial derivatives with respect to x, y and z. Now if we wanted to define the second order partial derivatives, we can take the derivatives again, but the condition is that the derivatives should exist and the limits should exist. So how do you obtain the second order derivatives? You have this quantity and you have this quantity. So what you can do, you can take the partial derivative of this firstly with respect to x and then with respect to y. So you have this double derivative of vector f with respect to x and the double derivative of vector f with respect to y and then x. And here you can take the partial derivative for this one. You can again take its partial derivative firstly with respect to x and then with respect to y. When you take it with respect to x, you have this double derivative which is the mixed partial derivative, where you have performed the derivative firstly with respect to y and then with respect to x, and this is the second order partial derivative with respect to y. These behave in a similar way as we already know for scalar functions, right? For vector functions also their behavior is same, and moreover the properties are also similar. So that means we can say the partial derivative of the sum of two functions is equal to their individual sums, right? And these are the same properties where we have just replaced the ordinary derivatives with the corresponding partial derivative. And this is the partial derivative with respect to x. We can also define the partial derivative with respect to y and with respect to z. This is up to us, okay? And this is the last property. So now let us move on to the next important topic that give you insight into various physical phenomena. Now what is this? That operator. First of all, you should know what is the meaning of operator. Operator is the one which operates on something, right? Which performs something. For example, this d by dx, this is the operator. This you can apply onto something, some kind of function here. Similarly, you have studied about integration. So this is an operator which you could apply onto some function, right? So there is no meaning of existence of these operators individually. So they will have some meaning whenever you apply it to some kind of function. So here we are defining another kind of operator which is popular by the names del or nebula, right? And the symbol is this triangle reversed. So this is the del operator and it is defined like this. So it relates the vectors. So this operator, it relates the vectors and the partial derivatives. So basically, this, what is this? It give you the change in x in the I direction, the change in the coordinate y in the j direction, and the change in the coordinate z in the k direction. and this is a vector operator. That means it will apply onto some. This is a vector operator. Why? Because here you can see the directions involved, I cap, j cap and k cap, and moreover this vector operator behaves similar to ordinary vectors because it could also, so I can say it could behave as a vector, and moreover this operator is very useful to define various important physical terms, which are this gradient, divergence and curl, which we shall see in the upcoming lectures. Now, what is this gradient, what is this divergence and what is this curl? This is what we will discuss next, right? Okay.